All right, welcome to today's live stream. We're going to be building our latest Smart Aquaculture code into a container image and deploying it to Google Kubernetes Engine and explain how that deployment works. So let me share my screen. Okay, we have a bunch of changes here in VS Code. Let's see, we got some new features for implementing multi-tenancy and more advanced access control into the site. And we moved the home page into a separate site routes class so that we can have a home page that is customizable and lets us load some data related to our smart aquaculture information. So like I'm running this site right now, and if I go to localhost colon 10230, which is where I'm running smart aquaculture for local development, then it it shows that we're tracking 16 fishing docks and 28 fish processing plants. I think I just need to fix this icon before I push this up because the icons are a little messed up. So let me double check that in the code. If we go to homepage.htm, the WebAssembly template, we have an icon here, but I'm going to close other files and open up fishingdoc.java, where we define the actual icon for this, which is font awesome duotone, font awesome regular, Bridgewater. So let me see how this looks in here. Go refresh. Oh, I'm gonna get rid of duotone for now because I don't think we actually enabled duotone in this site. And if I refresh this page, oh, let me see. What? Let me check our Font Awesome kit. So I go to fontawesome.com. I go to my account. I go to my kits and I go to Smart Aquaculture. And what have we enabled for settings? We have enabled regular. Oh, duotone regular and brands. So for some reason that's not working. Let me check all of these models, or let me check the site again. So these icons look fine. I think WebAwesome might be struggling with the duotone for some reason. So I'm gonna enable regular and save changes to this kit so that we can have both. And then I come back to the VS Code, I remove this duotone, and then see if the icon appears. Let's see, it still didn't appear. Oh, there it is. Okay, so we have that symbol for fishing docks. Let me add fa2xl, and it's going to make it extra big. Okay, that looks better. And then the one that we use for fish processing Java is here. So we we use fa regular industry windows, and then This goes here. And now we have a fish processing plant. Let me just make this look a little bit better. We want to stack these things. So I'm going to move this down here. So grab all of this stuff. Div. Okay. That looks a little better. All right. For the next step, we're going to push up this code. So let me check everything's working here. We got user 1. Let's see. So we have these map models in Louisiana looking good. So if we want to build this container image, what we're going to do is check what static files have changed, and there's a lot of changes, and then check what Java source code files have changed, and there's a lot of those changes as well. So we're going to first commit all of these static file changes, 1 through 86, git add -i, add these, add anything that didn't exist before, like this file, and git commit commit these latest static file change. All right, so those get pushed up to GitHub, and then we commit all of the source code changes in the Smart Aquaculture project through 62. Git commit -m latest features built for multi-tenancy access control. Git push. So what happens here is a container needs to be built. If I go to Quay.io and search for aquaculture, I see this repo, which is in compute.org/smart-aquaculture. Let's check the builds. Look, it's already running a build authored a few seconds ago by Computate with this commit, latest features built for multi-tenancy access control today at 11:45. So it's already in the process of building this main branch. So that's nice because we can build a little automation to help us build this container image. This is going to take, it's going to take a little bit. So while that's going, I can explain how things are deployed in Google Kubernetes Engine. So let me pull up Google Kubernetes Engine here. So this is a cost-effective way to deploy your containers, but it's still expensive and it's very fluctuating the price, how much compute you use and how much you're going to get billed. So so it's just it's a little bit hard to predict how much things are going to cost you when deploying to the cloud, but the nice thing is the cloud provides is automatic networking. Networking is really the hardest part of deploying things to the cloud. So if you take a look at the section on gateways, services, and ingress, let's take a look at ingress here. You see I have 4 sites deployed on Google Kubernetes Engine. I have a Keycloak single sign-on server. I have my computate.org website running. I have Smart Aquaculture running, and I have another site called trailblazehunting.com. And so these are all exposed as actual routes with IP addresses and domain names. And there's, let's see, there's front ends. Let me see where if I go to VPC network, I think here's the IP addresses. So I configure static IP addresses for each site that I have. And this one's for computate.org. This one's for Smart Aquaculture. This one's for Keycloak. This one's for Trailblaze Hunt. And so you get those IP addresses, and then you set up your workloads, you deploy your workloads, and you set up the networking, let's see, gateways, services, and ingress. So there's a corresponding Keycloak service, which is internal networking, and there's a corresponding Smart Aquaculture service and a computate.org service. So all of these have internal networking, and they also have external networking through ingress, and they have an IP address. So all of these are managed by the cloud, and it also manages like the TLS certificates automatically as well through various rules that you can define in these ingress things. I'm trying to remember if I put what's deployed in here. Let me shrink all of these folders and then check Smart Aquaculture, customize, overlays prod, Smart Aquaculture. So yes, I have defined how this site was deployed in Google Kubernetes Engine in the source code of Smart Aquaculture. So you can see I created a front-end config called Smart Aquaculture. Which specifies redirect to HTTPS
So
true.
this is your container right now, right?
This is these resources that I'm talking about, how Smart Aquaculture was deployed. I had to put all of these configurations up to get it working. And the actual container is defined in this deployment here. We specify the containers here, and we specify the environment variables that the container uses. We specify the image that's currently being built, the name of the container, the ports to open, and the readiness checks to perform, how many resources are given to the to Smart Aquaculture, like 0.75 CPUs and 1 gigabyte of RAM. We specify the host name here with this IP address in case there's a network glitch within Google Kubernetes Engine, which has happened before, where it wasn't recognizing the IP addresses weren't mapping to the host names for some reason for some period of time. So I specified these here. Anyway, this is how the container is deployed. Is that what you were asking about?
Yes, yes.
Yeah. Right. So this deployment points to this image, And if we copy this and we go to Quay.io, you see, let me open a new tab. If we go here and go to tags and we say fetch tag, it says podman pull quay.io/computate.org/smart hyphen aquaculture colon latest. That's exactly what we put into our deployment here. You got to match those up. And then it'll run the latest as soon as this finishes building. Actually, what we got to do is set the replicas to 0 and then to 1 again, and then it'll bring in the latest container image. So a few other parts to this. I was talking about the service earlier, and this is the service. It services in Kubernetes are for internal networking. They're not exposing anything out of the cluster. It's all internal. But we have to match these labels to what is in the deployment. So if we compare this service to the deployment, we should find the same match labels here. App, Smart Aquaculture, deployment, Smart Aquaculture. We make everything match. And we connect ports. So this 10230 port in the service matches a port defined in our deployment for this container port. The cluster port is for high availability service. So we can enable high availability in our service like we have done in AI telemetry. But right now in Kubernetes, I'm just running one pod because we don't have a lot of traffic right now and there's no reason to cluster it right now. But in the future, we can add clustering and high availability to this container image deployment. We set up a certificate so that Google Kubernetes Engine automatically manages the networking.gke Google Kubernetes Engine. They manage the certificates for Smart Aquaculture and keep it up to date so that we don't have to. And we set up the ingress so that people can actually access this service. So it's managed by Google Compute Engine or something, and it references the internal service, Smart Aquaculture, at this port we talked about earlier, this port 10230. So it has these annotations that says the ingress global static IP name is SMAQ, and this corresponds to let's go to VPC network IP addresses. It corresponds to this SMAQ IP address. So we match that up. We set the ingress class to be GCE. This tells Google Cloud to create an external load balancer to realize this ingress. And we said use the managed certificate called Smart Aquaculture. So that we saw earlier, which is this. It's this managed certificate called Smart Aquaculture. What else? Front-end config, Smart Aquaculture. So this references this front-end config here that sets up redirection from an insecure, if someone typed in http://smart smaq.computate.org, it would redirect them to the secure site with this response move permanently default. That's how everything comes together here, is through these labels or annotations. I mean, labels are different. But these annotations tell Google Kubernetes Engine what we're going to do with this networking.
Yes. I'm thinking about it. This is a great smart aquaculture hackathon race to set up your ingress and egress.
Yeah, it's good stuff. It's took me a while to figure out, but now I've gotten the hang of it, and it was quick for me to deploy the Smart Aquaculture site because I knew the process of deploying all these resources. So we can check if this image is ready. Let's double check. It says Docker file build completed and pushed. If we come, let's check the builds. Yep. It says it updated main and latest. Perfect. So now I need to get, I need to change my context here. If I do OC config current dash context, you can see I'm connected to the observability cluster in the New England Research Cloud. So I need to change context. OC config use context GKE. And then this, this lets me into Google Kubernetes Engine. I can do OC-N, which namespace? It's called Smart Aquaculture. So I do OC-N Smart Aquaculture Git pod. You can see there's this one pod there, and I can do OC. So this is directly connected to smaq.computate.org, and the site is up right now, but we're going to bring it down for a sec. Let's see, yeah. So I do delete pod dash dash all, and then let's watch the pod start. So if I currently go, it tells me this error server error. The server encountered a temporary error and could not complete your request. Please try again in 30 seconds. Now, you can avoid this error through high availability because this is all possible, but we're just keeping this deployment pretty simple right now since this site is still very much in development. But what's happening behind the scenes is some events. So it should be pulling down the container image. So it's not ready yet. Oh, it says it's running. So then git logs, pod, git logs. Wait a minute. Oh, sorry, it's not git logs, it's logs. So it says the run completed, and let's check the pods again. It says it's ready, 1 out of 1. Before it was probably, see, it did all of this stuff. Before it was 0 out of 1 ready, container creating, but now it's 1 out of 1 running. And if we refresh the site, then we have our updated site with the latest features. Wonder, oh, but this doesn't look too good, the search. So we got to keep working on the site, but um, currently it shows the time zones. I actually want to not show the time zones here because they're not really relevant, but they're relevant to other parts of the application. But at least it shows how development and deployment can be done within this type of application and container and Google Kubernetes Engine.
Mhm.
So thought that would be useful to show. Yeah, let's see. So Dwayne raised his hand. I'm just, you have a question?
Yes. So when we're doing this, we're in OpenShift and Fireware, or Fireware is an abstracted away, or
Oh, Fireware.
Mhm.
So Fireware, if I check a different namespace called Scorpio Broker and get those pods, Fireware is currently running. It's the Scorpio Broker. And if everything's working right, if I go to fish populations and oh, let's see. No fish populations found. So let me check. Wait, no, no, no. We don't have any fish populations. I was trying to go to fishing docks. If I go to fishing docks and I click on the first one, Slavich Oyster Dock, what we should see is some NGSI LD context data. Yes. So this is the world of Fireware when it comes to smart aquaculture. They have a certain identifier pattern for identifying objects. What's the term for this? It's like, well, it's NGSI LD identifier, but it's like a unique ID that could be used across um,
Yeah,
organizations.
yeah, in libraries we have concepts for persistence, and like for publications they get an identifier, and some identifiers get a temporary identifier, and then after you get it published, you get a permanent identifier. So this is like a permanent identifier almost, I would assume.
Yeah, exactly. It's the same concept. Um, because Fireware data is meant to be shared with other data spaces. Um, they're experts in setting up policies and contracts for how to share data across partner organizations.
Mhm. And so that's another marketing thing. We can say that our data is all federated, or can we say that or not? Or it could be federated.
Yeah, so what is federated data exactly? Integrating data from multiple sources without physically moving or copying the data. Um, what it what we're showing is that we have Fireware compatible data that could be federated um, or become a data space. If people were interested in our fishing smart aquaculture data, then we could become a data space, and it's pre-enabled with those capabilities.
Yeah, that's awesome, because then sovereign data is the next extension of that. Say, hey, now we have sovereign data. Yeah.
Yeah, sovereign data. The multi-tenancy features that I'm adding is definitely, it helps with sovereign data. It's a similar, it's a related concept. And and these Fireware related fields are ways to separate your data. Like we say here, this is USA, Louisiana. type data as part of the NGSILD path. So we're kind of localizing the data.
This could be a new training for librarians, to manage communities' data with Fireware. That could be quite a nice job for them.
Yeah, it could be. It's a good standard that believes in federated data spaces, unique identifiers, um, and context for the data. Um, for example, if you're wondering what do they mean by location, and you go to this NGSI LD context and pull up location, then here is a dedicated page devoted to location information. So it says GeoJSON reference to the item. It can be a point, line, string, polygon, multi-point, multi-line string, or multi-polygon.
And that's awesome because now you're also data curating it.
Yeah. So everything is perfectly well defined. It's like if people say, well, what is smart aquaculture data? What do you have? Why would we be interested in your data? Like, dude, we got the context of everything here. We've already defined it. So you can learn more about it. It's all it's this standard format that Fireware promotes that lets you define every field and all the data. If you look at, for example, fishing dock, let's see. So, um, smart aquaculture. I forget how to follow the links sometimes, but we set up information about fishing dock and which fields it provides. You can go to um, you can go to github.com/computate-org/smart aquaculture static and WebAwesome, Fireware. Um, yeah, this is where all the data is defined for a fishing dock, and you can understand what the model is for. Well, that's not a very good example. There's the attributes, address, color. Um, I think we need a little more work because I feel like some information's missing. But this is the concept. It's defining everything about the model so that you can look it up. What a
Awesome, awesome.
schema. But it's a little bit, it's missing some information, so we got to go back and work on that. But we're trying to best support the Fireware community. We're almost there to make it all perfectly compatible. And this is how the data looks. It's very verbose. Um, like for the name of this fishing dock, which is defined here, it's defined as this blob of JSON that includes this is a property, this is its value, this is when it was observed, and it's like the full definition with extra context of what is this fishing dock.
Yeah, it's almost like an ontology. You know what I'm saying?
Yeah. Yeah, so that's we're trying to implement the latest open source standards for data spaces, federated data, all these types of things, and put it on a map and give everything a dedicated page so that we can report on these things. Yeah, so there you go. some reason I can't get out of sharing my screen anymore. Let's see. Zoom. Oh, I've got so many Zoom things open. Zoom is not working good for me anymore. I might have to stop using Zoom. Oh, geez. You guys can still hear me?
Yes, we can hear you.
Yes. Okay. Well, I can't stop sharing. It's like now I have like all of these Zoom windows open. Oh, great. You guys know any better webinar tools? Maybe Google. I don't know. This is not good if I can't even get back to my window. I'm gonna have to, well, I'm gonna have to fight with this later, but maybe we'll just end it here because I can't control anything anymore. Any other questions you guys have?
Awesome,
No,
man.
not
Awesome.
so far.
Awesome.
Okay.
Yeah.
Thanks for joining.
Yes, thank you. I have that meeting
Thank you,
tomorrow at
Aaron.
12. So, you know,
Okay.
See. Bye.
but I think it's my last
Bye.
one at 12 tomorrow. Okay. All right. I'll see y'all next.
See.
Okay.
Okay.
All right. Bye-bye.
Bye.